This is video number 5 for sections 7.3 and 11.2, an application problem. We'll wrap this lesson up by looking at this application problem. It's a great problem because it both reviews some of what we've done previously as well as brings in the square root method. It is one of these scattergram problems. Let's take a look. Here's our let statement. We've got P being the percentage of Americans who say they are very happy at time t years since the year 1970. So the idea is somebody has been taking surveys in various years, and here are the results. You've got some years, and you've got, in each case, the percentage of people who said, I am very happy. Part A says, as usual, we need to adjust the data to fit our variable definitions. I don't think we have to adjust the second row. These are the percentages, and that's what P stands for, the percentage. But T, as usual, does not stand for the year. It stands for the number of years since 1970. So 1972 would need to be replaced with 2, and then 10, 20, 30, and 40. Those are the variable values I will use in this problem for t. All right, then we need to go to the calculator and put our data in and make a scattergram. All right, so here's the calculator. Let's go through our usual steps. I go to the stat area. I choose enter for edit. Looks like I've got some old data in here. If I arrow up, hit clear and enter, that will wipe it out in each case. And then I just need to enter my data in. My t values started at 2 and then went 10, 20, 30, and 40. So I'll put those in. And then in the second column, that's where my y variables go. In this case, the p's, the percentages. So 30, 35, and so on. All right, so we've got our data now in the calculator, and our next stop is to turn on the plot. So I have to go to the y equals area and go up and highlight my plot 1 by arrowing up and hitting enter. And then I just need to use that great zoom feature, zoom 9, as the scattergram window, and I should see my data. And of course the handout asks what type of function should we use. I'm sure you are not shocked that this looks very much like a parabola, so a quadratic function would be our best bet. In our next step on the handout, we're being asked to write an equation. Well, the only way we've learned how to do that so far is by working with vertex form. We have to know the vertex. Well, that means I'm going to have to pick one of these points to serve as my vertex. It seems pretty obvious I should pick this highest point. That's our third data point, so that'll be our vertex. And then the handout says we need to use one other point. And in this case, we're not given a choice. We are told we should use the data point for 2010. That was the very last data point in order to finish off the problem. All right, so back to the handout. We've decided that we're going to use our third data point as our vertex, and we're being asked on the handout to use the fifth data point, the one for 2010, as the other XY point we know of on the graph. Let's remember the process here. Vertex form is the only way we've learned how to do this. That's y equals a times x minus h squared plus k. I have to fill in the vertex. Well, here it is, that third point. My h would be 20, and my k would be 36. I'm almost done right there. The only thing I still don't know is the a. Well, that's where I need one other point. We're using this data point for 2010, the last data point. It's that temporarily plug-in idea that we've been using all semester. So I take that x and y point, I temporarily fill it in. So 29 for the y and 40 for the x. And then I solve this little equation for a. Whatever I get, I'll go ahead and plug into my model and I will be done. Don't overthink this part here. 40 minus 20 is just 20. And then 20 times 20 is 400. And then subtract 36 from both sides. And finally divide both sides by 400. This would be the moment to reach for the calculator. I was looking for some sort of rounding instructions. There aren't any, but it turns out it doesn't matter. This A value came out to be a nice decimal. All I have to do to finish this off, now we have A, so I go back up to my model and I just need to fill in that value. That was the one last thing we didn't have. We'll go ahead and use the right letters here, and the directions do say to use function notation. So that means my final model would be f of t equals that A number we got times t minus 20 squared plus 36. We're saying that this equation does a reasonable job of modeling this problem. Now, one thing we could do is we could go back to the calculator and type this equation in and make sure we've done it correctly. I just need to go into the y equals area. I'll leave the plot on, but I'll go ahead and I'll type my equation here in the y1 line, replacing the t with an x. So this is what you should have, and then just hit the graph button, and the calculator will take you back to your plot and it will add in the quadratic function we just found. You can see, sure enough, it goes through this point as the vertex, it goes through the fifth point just like we desired, and it really does a pretty good job of summarizing the overall pattern here. So far, this has all been review. Let's now bring in our new material. Part C says, now that we have our model, let's ask a question. When will 20% of Americans say they are very happy if this trend continues? Well, I have a model now. It's got two variables in it. T is the years, P or F of T is the percent. In this problem, I am being given the percent, so I just have to plug that in the percent spot and then solve for the T. When I do that, I'll simply replace F of T with 20. And then hopefully what you realize here is we've got ourselves a quadratic equation, just like the type we've been solving. And in fact, there's only one letter t showing, which means this is a candidate for the square root method. Let's work through our steps. Now this is a little bit uglier with the decimals. I want to make sure I don't do any rounding in the middle of the problem. Step one of the method is isolate the base and the power. This t minus 20 squared needs to be by itself. So basic algebra steps, right? Subtract 36 from each side and divide both sides by that decimal coefficient. On the left, I'm sure that's not a nice answer and I don't want to do any rounding in the middle, so I'll just leave it. I can at least cancel out the negative signs. And on the right, I now just have the base and the power, the t minus 20 squared. Now comes the big square root step, right? Square root each side, square root, square root. Don't forget the plus or minus on the side where the numbers are. And then we can simplify. I've got t minus 20 now on the right. And on the left, I don't really have much I can do with this. I'm just going to leave that alone. And then just add 20 to both sides. And I end up with two final solutions for t, 20 plus that messy square root and 20 minus that messy square root. Now I know that in this lesson we have then gone on to simplify our square roots, but in an application problem we don't really care. I don't need exact answers here. I just need decimals, and the calculator certainly doesn't care about just typing this in. So that's the next step, is to type these two answers into the calculator. Back on the calculator, let me quit out of the graphing mode. And then I type the answers in essentially just like they're written. 20 plus, open up a square root. Inside the square root comes that division problem. 16 divided by 0.0175. Depending on your calculator, you may need some parentheses there. I'll arrow out of the square root, hit enter. There's my first solution. Remember that great entry feature in blue above enter? If I just choose second entry and then arrow myself over to the plus, I can replace the plus with a subtract and very quickly get my second answer. So those are the two t values that are solutions. We generally round our t values to the nearest whole numbers, so it looks like we've got 50 and -10. All right, I've jotted down the two answers we got. All I have left to do is interpret those things. The problem was looking for actual years, so I go back to my let statement. Remember, T stands for years since 1970. Well, -10, that would mean 10 years before 1970, so the year 1960. And 50 would mean 50 years after 1970. That would be the year 2020. So we're saying if this pattern held, we would expect that back in 1960 and in the future year 2020, 20% of Americans would say they are very happy.